All right. So the final boss of the space industry is that of the single customer issue, that being the government, NASA, ESA, JAXA, CMS, Roscosmos, the DoD, the Air Force, the Space Force, whatever. The government is the only real customer for space in general. Or at least this was the case until Starlink, a telecom company which can generate immediate revenue and drive the demand for further rocket development. Every Starlink customer is in some way paying for the development of Starship, and now others are copying this concept. It's smart, but it's ultimately limited. It gets us bigger, cheaper rockets, but then what? Elon says Mars fleet. Cool, but that doesn't lead to more revenue. I think his current plan is to accrue enough wealth that he doesn't need to worry about profitability or economic sustainability or revenue or whatever. He can just fall on the sword of his equity, and from this sacrifice, a Mars colony will grow, and future generations can figure out the economics later. As noble as this may be, it hasn't happened yet. And even if it does, it still won't solve the single customer problem. So my question for you gentlemen is, what's next after Starlink? What do we do with these great big rockets Uncle Sam and Starlink fans have funded? Our ship has arrived. Where do we go? And what do we do to ensure we can keep going and doing?
Well, I think one of the key components, like you mentioned, is actually marketability of a product. If, Starlink is providing a service, people who fund that service help fund the income necessary for further development of the company. One thing that I see in the near term that's very likely to happen is that you are able to move a lot of processes that we're using on Earth into space using the vacuum and either full sunlight or coldness to your advantage. I do see an issue with data centers' exponential growth. I believe it's a good place for them, but it also depends on what is the immediate, needs. Right now, getting things to the moon, to space, that's very difficult. And so what we need to do is come up with marketable solutions for that infrastructure that's already in place. One of those is oxygen. I think that oxygen and its byproducts, which are reduced metals, is an extremely viable market. And it's probably the most near-term market that I can think of.
The big goal here is eventually to begin to colonize space and move humans and life into the cosmos. So with this launch capacity that we're creating here, what we need to start doing is looking for ways to begin to use space resources, the matter, space, and energy that's there to realize space-based power and O'Neill cylinders and things like that.
In a way, the Starship itself may be actually the tool which may be overused at some point. Every possible industry trying to do something up there. And I expect that it may come from, everybody has read something about tourism, orbital tourism, space tourism, whatever. But for all the options which were discussed for space-related industries, like crystal growth or some particular protein growth, some of them may rapidly just become the first unicorn to enter this area. And in a way, it's not fully possible yet to guess which one, because it's up to particular marketologists or just probably billionaires who may push some particular business to orbit because they may have the tool to do it.
Well, we need to think about first starts or startups in general, because you need money or resources and whatever to make even a single Starship launch. You need to have this money, or you need to create some proposal which can attract some investments. So before you do significant work on the moon, before you achieve significant results compared to whatever we may have seen in a recent decade, or the maximum what we have seen in past 2 decades is a few landers which successfully or partially successfully landed on the moon. If you compare this piece of technologies which did land or attempted to land to the amount of technologies, machines, and processes which has to happen before you can launch anything from the moon, and anything in useful quantities to become a product, it's a very big gap between such efforts which we have seen and with the efforts or results we need to achieve to be able to make anything useful with the moon. So the journey starts long before moon will have any production capacity. You need to create some vision, or you need to create some company or whatever which attracts resources. So basically, Starship becomes a reality, and we urgently looking for some sort of product which can be created with the help of moon resources. It quite a high bar to reach.
Yeah, one of the key points to getting to a profitable industry in either on the moon or in space or beyond is to have different levels of how you achieve these goals. One of the first product is probably going to be power. There's a lot of need for power for any process that you're going to be doing. One of the main things that needs to be looked at is how can we produce power in situ from, lunar substrates. The other possibility is to produce stuff for low Earth orbit on Earth and use that for any infrastructure in between Earth and the moon that you might need for either communications, refining. There's an entire industry on the moon. It's a lot of the same things that we have here on Earth, we can process and make on the moon. Not to say that those are the first things we should make, but in the end, we probably are going to use the lunar regolith for industrial processes.
I may suggest that it's the first step of big private space after Elon and after Starlink. Maybe propose something on the lower Earth orbit, or at least not too far from the Earth, not on the moon. But, well, I envision it as a laboratory or hotel or any complex of structures supposed to create something or store, well, basically anything. But for this particular item, let's call it first big machine, lots of additional infrastructure may be needed. And to create this, or to make it more sustainable, there may be serious need to get some local resources from moon or near Earth asteroids or any other source other than Earth itself, which will take us to our lovely blob of regolith, which we are talking about.
Yeah, the first product is information. It technologies and understanding how to make this or that in space. In space, on the moon, in low Earth orbit. So information continues to be the first product. It's not like NASA mining science, but it's next step. And here we can do certain activities in low Earth orbit to improve our understanding how to produce stuff in the vacuum. And it will be helpful to any processes which happen on the moon. So the first step is indeed to make some useful contraptions, and I agree with it. Maybe laboratories with teleoperated production or testing, and it's possible to deliver some seed in the orbit and materials to it to be able to make some tools, scientific or production tools out of those materials. And researching and development, how to do it, is the product by itself.
Yeah, I have to agree that research and development is absolutely a product in itself. The evolution of technology itself is also going to probably dictate a lot of the next generation items that we're going to be either putting in to lower Earth orbit or we're going to be creating on the moon. One of the things to look at today is what are we currently involved in? And if we look at okay, we have say Artemis, we do have a project where we are going to the moon. They do have a station set for that lab, and they will get some good results from that. But to get to the moon safely is an issue. One of the main products I think on the moon is probably going to need to be some infrastructure for whatever delivers the humans to the moon, whether that be a landing pad or solar and landing pads solar is brought there before, and the landing pad is made. I think the first product that's going to be made from lunar regolith is probably going to be sintered regolith, or whether it's laser centered, microwave centered, solar centered, that hasn't been decided. But the product itself requires large geometries, and it's not something you're going to bring from Earth. There's a lot of different markets for that and different research and development that needs to be considered.
So do y'all think it's possible to sell this R&D information or landing pads to customers outside the government?
I think that there's other spacecraft as well that would probably use that infrastructure that are, at technical readiness levels that are pretty close to where we should probably be. The one thing that you really need is redundancy. And with simulations and stuff, you give simulations information and such, but you can't get that information unless you actually visit that place. And going to the moon and actually getting that data in a way that's not artificial is incredibly important for the artificial process to evolve. So there is, a huge research and development market for any type of lunar infrastructure right now. NASA obviously invested a lot of money, but there's also other companies worldwide that have done the same. It's a very ambitious goal, and the difficulties that are along the way, a lot of people don't understand, are very, very difficult in the beginning. But once they're refined, they can be very profitable. And just like any type of exploration into something that's unknown, there needs to be proper research and development. so that there's some type of redundancy and safety and also, non-failure of the product that you're making.
In addition to data and infrastructure on the moon, maybe a little bit afterward, one product that could be sold pretty quickly, I think, would probably be something like oxygen. Of course, you do need the capacity to launch mass from the moon, but oxygen takes up about like 80% of a rocket's mass. So if you were able to source this from space and deliver it to low Earth orbit, you could potentially bring the cost to bring things outside of low Earth orbit much farther than they are as it stands, bringing materials from Earth, bringing the oxidizer from Earth, like reducing the number of Starship launches to have a single refueled Starship in orbit from like 9 to maybe just like 2.
Yes, it can be significant reduction, but of a few launches. Elon obviously maybe considered as a valuable client in such a product, and maybe it will be so critical for him that pretty much guaranteed. But still, to deliver even for one Starship, it needs to deliver about 2,000 tons of regolith, and it needs to have capacities for processing of it in orbit. It demands significant capacities as of equipment and what can be done or is done already. No matter you use big mass driver, or whatever. It also requires significant infrastructure for processing of the materials and to store and do actual refueling of the starships. So a lot of work needs to be done. And a lot of work means a lot of money.
Yeah, I have to agree. When you're trying to extract 2,000 tons of oxygen from lunar regolith, the amount of reduced metals is going to be probably double that, if not around double that. You have to ask yourself at the end of the day, what is more valuable? Is it the oxygen or is it double that amount in reduced metal? And it depends. In the beginning, it will probably be the oxygen because you're going to need a way to get that reduced metal somewhere to where you need it. You can use the oxygen and reduced metal as a propellant. You can also use it for infrastructure. But the point is if you're going to produce 2,000 tons of oxygen, you're going to have a lot of byproduct. And if you do it in a very efficient manner where you set up a very small infrastructure, just to produce this oxygen, and it's the only thing you're producing, you're losing a lot of valuable product in the manner. So I do believe that oxygen in the beginning, but in the short near future, the next product would probably be reduced metals and hopefully in a usable form.
And in addition to the raw materials themselves, processing those into additional processing equipment or power generation itself can be a service. Being able to manufacture things in space for space use for customers on Earth to purchase already installed in orbit would be hugely valuable, and you could do all kinds of crazy missions with them.
In a way, the very idea that actually right now already it's possible to install some manufacturing facilities on the moon to process regolith into something. Like if we are already in a status quo where it's thinkable, it automatically creates a huge market here on Earth because people would like to improve the existing capabilities. Like we are not coming to the moon with the equipment which is able to process regolith 100%. So in a way, testing this equipment is one more little market, which is kind of built into the whole trend we're talking about, which can be forgotten, but it also may create some additional value for all the other elements of this chain.
So for oxygen export, should we refine that oxygen on the moon and pack it into pressurized vessels, which I guess would have to be made of metal themselves, also refined from regolith, probably something, I guess, aluminum, and then launch this combination of concentrated oxygen in a container, which is also concentrated metal, which might be melted down and reshaped into something like a truss or an electrode? Or should we just launch raw regolith into orbit and reduce it there in orbit?
The latter, definitely the latter. There's several reasons for that. I'll list the big one first. In orbit, you have potential for basically never-ending sunshine. So double the energy immediately from what you would get on the moon. And that's not counting like some South Pole base where the sun is shining 90% of the time and you have some giant like rotating vertical solar array. Double the energy immediately. There's no ground in space, which is re-radiating its heat onto your radiators. So you also have double the effective radiator space. So this creates a very steep energy gradient from which you can derive much more work for the same amount of energy in space. So that's big reason number one. There's a few more reasons too. Not having the day-night means that you don't have the terrible temperature swing, which is really a significant issue. Some just sort of bulk materials themselves can fail from the contraction and expansion. Metals and stuff can microfracture. Ceramics can spall. So that hugely simplifies maybe some of the R&D needed to figure that stuff out. Also, you have just generally more control of conditions, temperature being one of them, but also G-forces, right? You can't get rid of the G-forces on the moon, but you can generate G-forces through centrifugal force, and this is a pretty good analog for natural gravity. So you can get away with things like density separation, like separating slag from metal in some electrolysis cell or something like that. Also, in space, you are closer in terms of delta V from the Earth. So things like imports are a lot cheaper to bring to some orbital refinery than it is to bring all the way down to the moon. You will still need to maintain some degree of production on the moon. To get to a mass driver, you need to have the ability to gather regolith, process it into a projectile, load it into a mass driver, and capture energy to launch it. And this will require a lot of equipment, probably more than you can feasibly launch from Earth, just monetarily. But even after the mass driver is built, you would still want to keep some industry on the moon's surface. For maintenance purposes, for one, entropy will beat anything eventually, especially on the moon's surface. So being able to remake droids and stuff like that and solar cells will always be necessary. But more importantly, if you want to continue expanding your ability to launch materials out, you will still have to keep making more mass drivers, bigger mass drivers, et cetera, et cetera.
Refining in orbit has a lot of unknowns where you create a lot of microparticles in some type of an orbit. Then you also have your tailings, so you have to use 100% of your mass. And if we could figure out how to do that here on Earth, then we probably wouldn't have a lot of problems that we already have. But the reality is that when you need things, they don't exist in the same quantities. You're not, what are you going to do with 100,000 tons of silicone of all that mass in orbit? It could be advantageous for further development, but it can also be a problem in initial development. One of the things that we probably know the least amount of knowledge is of how refining in low gravity will actually work and what its benefits are, and what its hurdles are. Like if you had something that needs to survive a lot of G-force, well, that's pretty easily fixed. But when you talk about throwing a whole bunch of dirt into a capture vehicle or something, how accurately can you get that to stop accelerating, not destroy itself, and then what do you do up there? And so you do have a little bit more power, but it's kind of like one of the power is, if you're thinking of solar, yeah, then that's the case. But if you have nuclear on the moon, you kind of really have a 24-hour power source, and then you also do have the night of the moon as cold and so on. You can plan things around that for that advantage, like cold annealing or something like that, cold welding, stuff like that. So I think that it's fascinating to want to refine in orbit around the moon. I just think that the research and development of the major hurdles that you would need to go through to get to that point needs to be developed a lot further than it currently is.
You mentioned tailings. The entirety of the moon is essentially made out of tailings. Its composition is essentially just basalt, which isn't really an ore of anything. It's just kind of a trash can of metals and oxygen and silicon. This is another reason why it makes sense to process things in orbit. Is dust or bricks made out of dust don't really care about G-forces. In addition to having waste in orbit, you don't necessarily need to expel it into space. You can make it into bricks and stuff like that, and they will just continue floating there. You can really use every part of the dust buffalo here. The benefit of being in microgravity is any solid material is essentially a structural material. Even if it's extremely weak in a gravity well, it will still be rigid when force isn't applied to it.
Probably it is possible to slightly reframe the initial question, actually, because in case of any particular product created from lunar feedstock, we may see at the logistical chain, which starts on the moon, it ends somewhere else. And along this logistical chain, we have some steps of processing. Like we start with quarry, then we process some, iron ore into steel, say steel bars or sheet, whatever. Then we are creating some particular details, compounds. Then we have whatever, automobile in the very end. And for any particular logistical chain or product, we may have some threshold after any particular level of our technological development that, yes, now it's reasonable to put the next step out of the moon to Leo or to any other orbit. Because first of all, we cannot put our quarries out from the moon to the lower Earth orbit, technically. We probably cannot put some early stage processing steps. For example, there is no point in just throwing out unpressed and just raw regolith piles from the moon to the LEO, but any further step may actually be considered at some moment. And vice versa, there is probably no point if we are aiming to create some complex devices from multiple parts, and not all of them are supposed to come from the moon. Some of them are too complex and manufactured on the Earth. There is no point to assemble, I don't know, randomly full engines on the moon itself. So we can think about the design of any particular product logistical chain in this way. And of course, for different products, it should be different.
So it seems like we've all kind of indicated that the moon is great for exporting mass, it's a giant ball of feedstock material already in orbit thing. But is there any point in actually trying to colonize the moon with people and plants? Is it a place to settle and live? Can the moon solve the housing crisis?
Well, I believe that it depends on what time of evolution you're talking about. I think that our main goal as humans is to move past the Earth. I think the first step is to take it to the moon. I don't necessarily think that humans should be the first thing, like as tourist industry on the moon. I think that it needs to evolve in a progressive nature. But I do believe that, the problems that we have today, even like, how we get to space and everything, will all be improved. I mean, we're not going to just sit in our current technology level. We're going to exponentially increase it. And if we do this in a logical sense, then the moon and then further should be probably the most economical method.
I don't think that we will see something like permanent populations on the moon. The moon is kind of a terrible place to live. I think Ian described it as a radioactive slag heap, which is, I think, probably not completely far from reality. Whether or not we find solutions for things like low gravity, there are some deep ethical considerations when considering subjugating people to be born and raised on the moon. If you don't have like centrifugal ring-shaped rooms that have slanted floors to sort of balance out the centrifugal force with the native gravity of the moon, you will have like really bad bone density and muscle density losses like you would in microgravity. So subjugating this to something like a child would be, unthinkable, especially if they don't have an opportunity to return to Earth because of it or something like that. The moon, I think, will be sort of, in terms of human activity, will be more like Antarctica, where we will have research bases and some occasional tours.
People on the moon, cities, etc., they see more like continuation of development as an accessory part of development what moon can do, what can be produced on the moon, spaceships, spaceship yards, etc. But moon is more like a mine, not like a second newborn economy which has to develop. It's not like a country which has to develop or increases its production capacities. The only goal of the moon is to deliver moon regolith to where it will be processed. Well, it will be turned in some useful stuff. And doing it in microgravity expands what can be done. It improves energy efficiency, etc. It's possible to be on the orbits where it eternal light, etc. At least almost uninterrupted energy supply. And then moon and its capacities does not need development beyond the ability to maintain capacities to launch regolith and initially establish such capacities.
So I think that if you have all this power and you're producing these products, you're going to have to fund it somehow. And there are going to have to be people probably as working on the moon. There'll probably be tourists on the moon in the beginning, I would imagine. There's a lot of people who would like to actually visit the moon, I would imagine. Whether it's healthy for them or not, that's not going to really dictate a lot of their decision. Their financial standing is, and their want to do something that is unique is going to drive a lot of that. If you have somebody investing in your, who's paying for your refinery, they're probably going to want to one day visit that refinery or habitat themselves, I would imagine. The industry should evolve a lot faster than the tourist aspect or any of that. But the problems that we think are very, very big today, they'll be solved. And gravity, degradation on the body, all the heavy particles, they're all going to be solved very, very soon, believe it or not. And then the moon is just one stop on our, journey out of the solar system. And we need to just like taking a boat to the ocean, we need to logically plan what islands we're going to stop at, where we can refuel, where we can get our resources, our food, all that stuff. And there'll be an interchange of people going from, let's say, Earth to space, to the moon, back to space, then back to Earth. And the amount of money or product or profit that can be created just from that alone can drive further development. And if we can't see past just, sending machines out of the solar system, which we've already done, we really need to look at us. And, if you wait long enough, technology will evolve that we won't physically need to go. We'll just be able to send a little probe or whatever and visit wherever we want, right? In the beginning, that may be like the far future case, but in the end, people are going to want to physically experience things, all their senses, every which way. And they're not going to want it artificially because it'll be too easy to do on Earth. There will be new markets driven by all different reasons that we cannot even think of yet. But if we limit ourselves to what we can do and what we're trying to do, then we really limit our capacity for future evolution of technologies. Even if we do something that doesn't work out, we learn from it so much that it betters man in ways that doesn't happen immediately, but does evolutionary.
It's quite useless to talk about future and future economic incentives for development or what can be or cannot be. Because in general, space can't lose. Reason for that is because of availability of energy in space. And it basically, this energy and volume of the space itself is abundant there. In general, if we start to move in space, it will be a great success and there will be plenty of uses and different business cases and etc. Problem is to start this movement. And this is more practical question, how to attract financial resources to the development of the moon at the beginning. Mars has his sugar daddy, Elon. They have SpaceX, which has Starlink, which is potential money source, which significant resources which allow to claim that Mars is possible and will be development at such and such way. Moon does not have such significant supporters, and its initial stage of how to start is more of a question. This information technology and learn how to do stuff in space is a very important first step, and potentially is a way to gain some financial support for the activity, because it has to happen maybe parallel with some moon stuff, or start even earlier than any moon activity. Because if we imagine now we have mass driver and it delivers regolith to our door, what do we do with it? We have no refined technologies which can do useful stuff from the regolith. Even this electrolyzers of regolith, it is a technology which has to be imported. So first step is to learn how to do stuff, and it will be useful for the moon when we have ability to send something on the surface to start the development process, and it will be useful when this development process ends with logical mass driver and launching Earth in the orbit.
In terms of lunar development, again, after Starship, we unavoidably would have we already have some incentives, and we highly likely would have few categories of human beings which would appear on the moon. First, tourists, which were already discussed in a way. Second, maintenance people, which may be needed there at least in some quantities. And I may suggest scientists, because there are lots of stuff which is much easier to research having active human beings knowing what to do than just robots, even with quite a wide range of capabilities. And in a way, all these human beings would be a research object by themselves, because they would give us, the humanity, some information about the behavior, health conditions, lots of parameters of human beings, sociology, for example, on the moon. And I may expect, as it was already mentioned, it may be compared to Antarctica, because living in Antarctic conditions in, say, 60s or 50s and now, in terms of comfort, it should be quite different. It should be more or less like this on the moon as well. So after the appearance of these first groups of people, we would learn how to maintain them on the moon. We would pretty unavoidably, since we're sending human beings to the moon and back, we would improve our abilities in terms of basically passenger transport from Earth to moon and back. And as it was already mentioned, the energy supply on the moon would grow in parallel with this trend. What it may lead to, for example, it may become possible to create, in a way, a shelter on the moon. And some billionaire probably may would like just to create his own little flat on the moon, and just to stay away from these nasty human beings from the Earth. Like, why not? In a way, it would be also funny because it would be an experiment of itself. Or it may become a base for other extraterrestrial or extralunar activities, because in 1 century perspective or 2 centuries perspective, the human population of the moon may be a function of human population of space in general outside of Earth. If we have some stations in asteroid belt or some expeditions to other corners of solar system, then pretty much as a byproduct, human population of the moon is increasing. If we are stuck and the moon is more or less our only place outside Earth where we may find human beings, then its population would be, well, few tens of individuals probably.
Fascinating stuff. Yeah, it also brings up a good point, whether it's in 100 years or 1,000 years or sooner, maybe even, the next decades. If we do discover alien life, whether it's, small biologics or even intelligent, which, is probably not in our solar system, as we know, we're probably going to want a meeting place where we're not going to contaminate the entire planet. That might dictate our future as humans. I mean, whether we, go somewhere and destroy a civilization unwillingly or unknowingly, or we think about it logically and a meeting. I mean, this is just fascinating stuff. I have to agree with almost everything you said.
There is no aliens in solar system. It's really not so useful to discuss how we will meet them or where. It's more sci-fi than any real stuff to consider in near future.
Well, something was found on Mars just a few days ago. This time really looking like very simple, but life, of course, it existed long, long, long ago. So still, maybe something, at least in terms of very primitive xenobiology. I would prefer to research some unknown bacteria or bacteria-looking organisms not on Earth.
Yeah, and preferably not with help of humans. Experts in technologies and learning how to do stuff in microgravity partially is the way to learn how to not to use humans to do this or that, including researching potential aliens, bacteria, or whatever.
And it should be pointed out, we've gotten like 5 guys. This time it's something like 5 times over the past 10 years. So it's never panned out yet. We'll see about this one.
Yeah, well, I think they did the null hypothesis for this one, so it does look a lot more promising. I'm skeptical. I'm not sure what it would take for me to not be skeptical, but it does seem like we're headed in the right direction, at least.
There's plenty of places that could exist life. I mean, there's so many. I mean, Europa, there's a lot of them. If you think about, we don't know everything about the moon. We know very little. We know as much as if you stuck your toe in some water. The, technology that we are naturally akin to evolve comes from the unknown. And I believe that, our future in technology is going to, be found in processes that could never have been found on Earth. And can only be found whether it's in space or in lower gravity or whatever. And to do that, you're going to need the infrastructure. And to have the infrastructure, you're going to need the power. If you're going to need the power, you're going to take the resources either from Earth or from the feedstock. And if you're going to use power, it's probably best to use it in the most efficient manner where the process is happening. So the logical step for further exploration is there. It's already there as the moon. And, if you want to get stuff into mass today, it's not unfeasible that you can just use, aluminum oxygen propellant or something like that from the feedstock. And you can literally probably 3D print a ship with today's technology as a probe at the very least, many, many times. So there's cases for machinery, there are cases for humans. If you leave humans out of the loop, then your ability to understand things that machines can't goes away. And that's where a lot of future technology and current technology has evolved from.
Moon is not the mine, Moon is not the stockpile, Moon is alien spaceship.
Well, nature didn't make things easy for us, and it's probably not going to be easier as we evolve. But the drive to find the unknown, to search for answers for things that we, don't understand, is going to drive humans, development of beyond the solar system, in my opinion.
Well, Mars and its finding of potential signs of life is a good example of not needing humans to make this research. But part of the problem for this Mars research is that there is not enough space capacities for us to send those machines or whatever equipment we might need to make such discoveries or researches, because it's expensive for us now. And Moon is on of the ways, and production on space in general is one of the ways to solve this problem.
Yeah, I think that unless we do some crazy population control or something, and we all decide that we're going to have a limited amount of children and everybody collectively on the Earth makes that decision, we have a serious issue. And that's that there's not enough resources or room on the Earth for humans to evolve. And if you think about it mathematically, the more people we have, the faster we can evolve. And if we can move past our current limitation, then we can absolutely not look at our resources as limited here on Earth, which would drive a lot of prices down for a lot of things that are what we consider luxuries today would be everyday items for most people. That's a little far-fetched, but, it's logically possible.
No, yeah, I agree. And I believe that standard of living is directly correlated with the amount of energy a civilization has. And of course, space is an energy frontier as well. But in order to do anything like power satellites, beaming energy back down to Earth, or moving our heavy energy consuming industries off of Earth into space, we need obviously mass and orbit from the moon. And like we talked about, mass drivers are essential to do that. Mass drivers are how we unlock the mass of the moon for human use. But between the first landing and the first mass driver, there's a huge gap. So my question for y'all is, how do we bridge this gap? What do y'all see as the most realistic stepping stone industries or products or approaches that could keep progress alive and attract funding along the way?
First, you have to ask, how expensive is the gap? If you can make a mass driver in 10 years and there is some cost per year to maintain operations, then you need to figure out if you need to have some income from that activity, or if you can just coast from some billionaire benefactor. Generally speaking, I don't see much of a faster way to make this cost increase than to have a human presence on the moon, which is essential to continue operations. Just having humans there means you need to pay for life support, food, water, but also transport. And that humans are the most expensive pieces of equipment you can send anywhere.
Well, we do consider ourselves valuable to ourselves. So we try to ensure that, we have all the comforts that we need along with us. And yes, that is expensive and those are resources. But what it really boils down to is money is just an object that humans use to justify convenience and resources. If we think about the resources needed to get to point A to point B, we have them all here on Earth in quantity. And we just need, a collective amount of people to pull towards a collective goal. If cost is going to the future development, it's only just going to delay it. It's not going to inevitably stop it.
And yet those are the conditions which dictate basically how everything is done already. So from within the limitations of money, how can we get to the point where we can develop the moon?
Well, I think the first step in development, lunar development, should be trying to create a power source in situ. In the short term, we need to create infrastructure for all that, but we need to figure out how to get to that point as well. I think those are step one that we should be, focusing on as far as research and actually development at the same time.
The ways to make money from the moon, before you have the ability to export mass, are somewhat limited. Tourism is one of them. That, as far as its profitability goes, I'm not sure if there's any sort of numbers for that, but obviously the investment you have to put into that is quite high. So who knows what the returns will be. Selling data, like we mentioned before, is a pretty big one. Being able to send materials, smaller amounts of materials through rockets, again, it's a maybe. TRL for that isn't particularly high for metal oxygen rockets.
Well, a mass driver is obviously the best and most efficient way, and choosing which one is obviously going to dictate what is going to be possible. But to get to that point, I think that we need to realistically look at what we already have going on and how it's going to develop in the future. And what we already have going on is that we're going to put some type of a habitat and infrastructure. They're probably going to bring power sources with them. But the next step is, what products can we actually make from the moon, and how do we do that in ways that we can figure out here on Earth that are pretty much going to dictate the amount of mass that we can initially start with. So I think that power, whether it's tourists or scientists or even the first missions, it's probably the number one commodity. And if we can charge for it like we do here on Earth, we can do the same on the moon. And it can be an actual separate industry in itself, just like mining can be a separate industry.
And it's really important to keep operating costs down as much as possible too. And we can teleoperate most of our robots and stuff like that from Earth. Is about a 2.5 second delay just from light lag, which is like a slightly frustrating Zoom call. As far as I'm aware, there isn't anything that you can't do strictly because of that light lag, as far as performing any sort of manufacturing or production activities. So if you could eliminate the need for humans to be on the moon, as far as workers and stuff go, potentially the cost could be as low as paying some guys to sit in an office somewhere and operate robots on the moon.
Limiting the goal which needs to be achieved on the moon is also one of the ways to reduce expenses on research and development and in operating support of the products. So if we want or need to develop some sort of shipyards on the moon, one complexity of the problem of investments of the research and development, and if we think about need to make one mass driver of some maybe simple construction and energy source for it and equipment which we also need to produce, which makes all the stuff. It's a lesser problem and lesser amount of efforts to put into the goal.
Okay, yeah. So if we could rehearse everything on Earth first, and of course we can't get the low gravity perfectly, but maybe if we could gather enough low gravity data, then we could develop pretty strong simulations. And it's not perfect, but we could increase our confidence of being able to send basically a starship sized 1 or 2 starships with, all the equipment needed to just race straight towards mass driver. And like one of y'all mentioned, the design of the mass driver matters as well. So like you have on one end like a very large coil gun or rail gun that's going to require a significant amount of infrastructure and ISRU materials to create. Railgun mostly being, a kilometer or 2 worth of aluminum. And I imagine you would lay that on some sort of prepared ground, like centered, glassified, or just, compressed using some sort of like road roller type thing. And then you also need the grid. You need to power it somehow. Maybe you import a reactor, or maybe you need to pace fields of solar cells and their electrodes and the electronics associated with those. All of these things could be planned in advance and rehearsed, and we could just have a day 0 to 100 function. That's an option. Another option is to go with something like the quench gun, which is basically the very high-powered version of a coil gun using superconducting coils. So the quench gun theoretically should be able to achieve very, very high acceleration rate. So then the gun itself could be very small, and you could fit it into roughly 6 or so starship-sized landings. And so you just skip the whole ISRU thing. But if you choose that route, then you're stuck with importing because you never invested in your ability to manipulate the world around you. However, there is a value in, showing that something can be done first, and then you could learn the ISRU stuff as with funds you're earning from the exports from the quench gun. And it doesn't have to be a quench gun. There's other very, high-powered type systems. These are different versions of what you might think of as a strategy associated with that seed. The seed being something that you import and then you grow from there.
All the testing, it 10 times cheaper to do in low Earth orbit than on the moon. So you do not test stuff on the moon because for any starship on the surface of the moon, it 10 starships in orbit and low Earth orbit. And if you send any kind of technologies and equipment which makes stuff for each starship you send on the surface, you can send 9 additional starships in the low Earth orbit. It can be more equipment, or it can be source materials for the equipment to learn how to process it, how to make products of the material, how to recycle, how to whatever. So it gets back to financing and information and knowledge of how to make things to be a product. And it can be the financing, or at least activity which attracts investments, if not product itself. And if we have a clear goal as ability to launch from the moon a significant amount of mass, then we can formulate clear technology path from the seed to the final moon product, like mass driver, without whatever human presence. Human presence is a product of main activity. It next step, let's say so. But you have to come on the moon prepared. It's not like the country development, which has to develop over time in many different directions with help of many companies. It needs to be army type stuff, marching from point A, like initial setup equipment, to the final destination of this process as mass driver, and scaling this up to be able to satisfy demands which we might have. Because if SpaceX has success, this is speculative stuff, but 100 launches per year was a number I remember from some of Elon's stuff, maybe more. It 100,000 tons of regolith in a year. It's more than your typical proposal, which you see today. So it's significant result, and it will require significant energy support of this. It will require significant mass driver, not mass driver which shoots, kilograms or tens of kilograms. It needs to be significant setup.
Well, I think that if you're going to go straight to mass driver, you probably need to have a use for your mass. If you develop some infrastructure and you develop your actual product first, and then you drive that mass to whatever you need. Like for instance, you want to build a spaceship from lunar material, and you use a mass driver to do it. Does it make sense to try to send a mass driver to the moon and then try to send some stuff into orbit to figure out how, which we have no idea, to catch it and then refine it in that environment? Or do we do something where we can send the finished product up, and then it can be built like up, in orbit for its end use case?
You asked a right question. If we have math, we have to have a use for it. It's possible to talk about uses of Mars, and I already mentioned if we consider SpaceX as one of potential clients for oxygen, it already hundreds of thousands of tons of regulate required to satisfy what they see as term possibility of how many starships they want to launch, and it will be only more from this point up. But it's a long time, and there are problems. But if we start with learning how to do stuff in space first and then go to the moon, when we have, let's say, 100,000 tons of mass, we know how to process this mass, how to convert it in devices, and then there are many uses for it, starting from energy, space energy beaming, which is quite solid case for money-making plan, or you can speak about data center and their energy supply. We do not need to make processors or motherboards. We need to make shell for data center. And its energy supply, its conditioning, its radiation protection, which will require plenty of mass. And when you use the same level of radiation shielding as for humans, then you can use regular equipment, regular servers to be operated in space as long and as good as they do on the Earth. You don't need space-grade equipment, you don't need space-grade processors, etc. If we start talk about uses of regulate, we can at least we can discuss more or less seriously at least few options how to use it, and those options will require not 10 tons, not 100 tons, thousands and 10,000s and 100,000 tons.
There are several methods to get from point A to point B, but I would imagine that if you have a lot of infrastructure developed along the way, that point B is going to have a lot more redundancy than just, betting it all on something where if one part of that fails, then the whole project fails. So I do think that maybe smaller mass drivers need to be explored, the different types, their efficiencies, and so on and so forth. And the best way to do that is to already have the infrastructure to be able to create that product in place.
Faster you reach point B, faster profit starts to happen, or how to say. Other activities, establishing infrastructure and etc., they are more a distraction than real product or real profit of activity. Because if we say we make a landing pad on the moon, it's good proposal and it's not hard to do, and maybe relatively easy to do. But how much do you think it costs? Or if we say we can deliver your droid from this landing pad to any point on the moon, well, if you send your Earth-made droid for research purposes, if it lands on the pad, we will deliver it at any point on the moon. Quite a proposal, but again, it's not billions. Beaming energy on the Earth, potentially 1 gigawatt of this beaming. It's about 800 millions of American money per year, and you don't have to stop on 1 gigawatt. 10 gigawatts, 8 billion. 20 gigawatts, it can be routed to the development of the moon, of the stuff on the moon. It can be routed to develop stuff in orbit, make things from this moon regulate in orbit. Faster you get to the point B, faster you start actual action for which the moon is the first step.
As space becomes more valuable to Earth, the more people on Earth will see space as a valuable place to be. And eventually, free market will begin to transition into space itself. And if there is exponential growth of energy and production, eventually the economies of space will begin to outcompete Earth even. And I guess at that point, we could consider space being colonized to some degree.
I only may add the little point that it was like there were essentially two futures discussed. The future where only one entity is actually colonizing the moon, building the mass driver, etc. And in this case, yes, we are certainly just leaping as fast as possible to the first big, nice mass driver. We may skip any number of other aims, tasks, potential products, because they are not as cool as involving lunar matter into the economy of solar system. Or there are actually more than one company, maybe a few companies, maybe tens of companies, which are doing something on the moon. And for some of them, building mass driver. Some of them are totally not into it, and they're fine just bringing in tourists and, I don't know, making TikTok videos on the moon. God, please no. And in this case, there is a chance for full parallel technological routes and chains leading to different ways of using the moon. So in a way, it is pretty realistic to see the second option as a scenario for the future. But probably still, if we are thinking not from the point of view of the scenario in general, but from the point of view of one particular company aiming for extraction of the highest possible value from the moon, we still should think in terms of leaping to the mass driver. So actually, both views are quite reasonable.
Setting one concise goal like this mass driver is probably one of the few ways to consolidate around something, because if we start to talk about flavors of different space proposals, then there is no agreement, there is no key to join efforts that much. NASA is some sort of consolidating entity, but its productivity isn't high in terms of our progress for the great space future. So when researching how to make devices, equipment from the moon regulate is also one of the way to funnel efforts of different companies in one technological tree, in one process of exporting from Earth to the space. Mass driver is also one big funnel to consolidate efforts and resources on this goal. And then when mass driver is working, one funnel connects to the another, and then it starts time of endless possibilities, endless whatever we want to do.
Well, I also believe that there's a strategic importance to whoever pretty much owns the infrastructure of orbiting lunar material around the lunar surface is going to have the ability to not only protect what they've invested in, but also defend against, like, stuff on Earth. So, it's going to be a little bit difficult to get countries to collectively do it. I would imagine, maybe not. That is such a high value that it might drive a government body or country to try to develop that sooner than later.
One of good qualities of the mass driver and moon product is that it's uniform in some sense. It's equal starting point for other activities, because in general, moon regolith is all the same on the surface of the moon. There is not much advantage of competing in terms of what to deliver from the moon.
All right, well, I guess let me just throw some numbers at you guys, and then we'll segue into a final question. So a Starship carries 1,500 tons of propellant, 78% of which is liquid oxygen, 1,170 tons of O2, and lunar regolith is 40% oxygen. So to fill up an entire Starship, we would need 2,925 tons of regolith. And to refuel a Starship in orbit would require 8 to 10 launches of another Starship carrying this liquid oxygen. So 3,000 tons of regolith equals about 8 to 10, and more likely 10 Starship launches for refuel. So here is an opportunity cost. Although this really matters more if a Starship wants to go beyond low Earth orbit. It's not necessarily an issue to refuel whenever it just comes to something like Starlink. So we still have a sort of demand-driven problem on one end, but for now, let's just focus on the fact that there is a need to refuel Starships in orbit with oxygen. If the marginal cost of a Starship launch is 10 million, then 3,000 tons of regolith saves about $100 million. This is not the value of regolith. Something is worth what someone will pay for it, but it shows opportunity exists if mass driver construction cost is low enough, which it should be, since as infrastructure, its cost can be amortized across launches, and then R&D can be amortized across further mass drivers. Not to mention the other uses of oxygen and then metals and the material economy that will develop from that. The byproducts of oxygen refining can be used to make trusses and solar cells and radiation shield walls and all of those other things, station building. And also the oxygen can be used for refueling other satellites and stations, not just Starships. So I do think there's an opportunity here. And when we discussed bridging the gap, or even just completely closing the gap between, that first landing and getting to the mass driver. But my question to close out is, what if Starship doesn't pan out the way we hope it to, and we are stuck with a much smaller capability? The Apollo lander had a payload mass of 3.5 tons, and Blue Origin's Blue Moon lander is aiming for something like 4 tons. So let's say in the absence of Starship, we can only land 3 or 4 tons on the moon at a time. And that's a pretty big difference, 4 tons to 100 tons. What then should the strategy look like? Are we doomed, or do we just have to make our robots smaller? So I guess this question is more like, to what extent does the size of the seed matter?
That's a really good question. One thing that we do know is that we have landed something of that, weight on the moon, and Starship is still kind of unknown. But if we do plan with just those figures, we end up with a lot more options. And yeah, it it's the same. You're going to have the same product. Oxygen is going to be necessary for a lot of the early development. It's part of the moon that is going to be probably initially the most profitable, and in the end probably the most profitable because there's so much of it by mass. So it would just be you start with a more refined process, but I think the end goals would be very similar.
In this case, there is a much bigger need for any ICRU manufacturer. But if we are still aiming for some lunar industrialization and for other planets and on cylinders, etc., we still need to take mass from somewhere. So in this case, we just need to send to the moon more ICRU stuff in smaller benches with probably higher efficiency, probably even better designed on the preliminary, like fully Earth-based stages. And we need on the earlier stages of our industrialization plans to be much more sufficient in terms of lunar material use than compared with Starship Case.
It does change things a little bit. You're probably not going to be able to have an industrial seed that can grow in regolith from 4 tons. But the advantage is that if you did have something go wrong, if it tips over or something like that, and you invested $100 billion in the thing, that you don't have all that destroyed. So that's nice. And there's also opportunity for the first droids to build some sort of infrastructure for later droids to come back.
It not changes much as initial step. First of all, it starts on the Earth. No launching capacities are needed for that. Then you start this. If it for the moon is 40 tons in low Earth orbit, and it's not so far off of Starship capacities, you can play quite comfortably with test them, and your stuff can be done in this mass size. Like that.
Tug.
You can make some sort of tug with ion propulsion, and it will increase potential payload size. So you can start improving situation by doing stuff in orbit. Also, safe landing is not the only options, as we all know from KSP, and it may be seriously considered to boost some initial starting conditions on the moon. In the same way as egg challenge, when it's dropped, it has to be not broken. Same or similar stuff may work for microelectronics imports, and you can use your production in the low Earth orbit to prepare such a basket. So there are ways to improve situation, but even without all the hacks sticking to the 4 tons, well, it sure has to be more smaller than what Starship could deliver. Maybe elements of the production has to be size of tabletop, but it's possible to refine the development path and the seat itself in this section. But if it's not possible, then well, you have to eat whatever you have, so you will need to send more than one lander. But I think in general it doesn't change much. Yes, it will makes it hard. It's just hard to confidently say. Maybe yes, maybe not. But it's possible to test that on the Earth if we are able to make something useful in the 4-ton range, which can produce from feedstock its components and such. Yeah, my final thought. I think it does not change. Starship or not, or space future is bright, and we can leap from point A to mass driver in a few years.
So is that all? Is this anything else? Or are we ready to wrap it up?
I'm good.
All right, cool.
We'll see what Magic Ian can do. Who knows? Maybe we'll get tens of listeners.
10.
If anybody makes it to the end, they deserve a.
Yeah, if anybody makes it to the end, you get a free email from me with my address. I'll come take you.
I'm leaving that in there.